Hello everyone. Already we have seen the types of governor and why the governors are used and how that governors are going to work, what are the various terms which are used in that governor. We have seen a simple type of governor, that is VAT governor too. Now we have seen the limitations also for that VAT governor. That is that VAT governor beyond 80 to 90 RPM is going to become insensitive. That's why next version of governors are generated or find out. Out of that, the first governor which has been generated later on the VAT governor is the Porter governor. Now we are going to see this Porter governor. In case of Porter governor, here you can see the schematic diagram of this Porter governor. In this case, these upper two arms are connected at point P to the spindle, which these arms can rotate along with the flying balls. These flying balls are connected to the sleeve. As the flying balls can move in outward direction, this sleeve may get lifted or it may come down. One can easily understand that if the speed will get increased, the centrifugal force, that is Fc, already we have denoted, which is equal to mr omega square. As speed is going to increase, that is omega square is going to increase, hence the centrifugal force will get increased. These fly balls will move in that is outward direction. As this is moving in outward direction and this P point is fixed, only these arms can move upward and downward direction because it has hinged over here, and the sleeve can move in upward and downward direction. Hence, because of the increase in centrifugal force, the sleeve will move in upward direction, and if the speed will get decreased, the sleeve will move in downward direction, and this sleeve motion is connected to the fuel supply system, and this fuel supply system is used for the supplying of that fuel to the engine, internal combustion engine. Now this is the what we can say the schematic diagram of this Porter governor. Now we are going to see how the forces are analyzed in this governor and how we can go for the controlling equation of this governor, as we have find in case of VAT governor. If you are remembering that VAT governor, in case of VAT governor, we have calculated it as a H is equal to 895 divided by N square. Now, as we have seen the Porter governor, schematic diagram of that Porter governor. Now for the analysis, let us consider that M is the mass of that fly ball, that should be in kg, units are important. Then W will become M into G, that is the weight of fly ball, that will come in Newton. Then M, this capital M, is the mass which we have seen at the center, that is the mass of central mass is the M, capital M, which has placed on the sleeve. Now this capital W is nothing but weight that we can calculate by capital M multiplied by G is equal to weight of that central mass, that should be in Newton. We have to place it into Newton. Now W we have calculated, then H is the height of that governor. Now height always is measured from the point P to the center of that fly ball in vertical direction along the spindle, that we have seen in case of VAT governor. In the terminology also we have seen it. Now N is the speed in RPM of that governor by means of which it is rotating. One can calculate it, so omega, that is angular velocity, by 2 pi n divided by 60, that will come in radian per second. Then this F suffix c is the centrifugal force due to the fly balls. When the fly balls are rotating, that should be in Newton. Then as the fly balls are rotating, that's why they will generate the force, and who is going to cover that force, and that is the tension which has developed in the upper arm and in the lower link. So we'll consider this T1 as a tension in the upper arm, that should be in Newton. Then T2 is the tension which has created in lower link, or we can say lower arm, and this alpha is the angle which has been made by the arm with the vertical. Here you can see the all parameters or terms which are used in this schematic diagram for the analysis of forces. Now here is the point P, this is the arm, this is fly ball. One more thing, that half part of this governor we are going to consider for the analysis, that can be implemented to the other half part too. It will be just replica of this part which we are going to calculate. So the tension which has developed in arm, that is T1. Here we have seen this W which is acting in downward direction. Centrifugal force is acting in the outward direction as this governor will start to rotate. Then T2 is the tension which has developed because of these forces which are acting on this fly ball. And this W, as we have keep some eccentricity, that W will not exactly act at the center line of the spindle. It will act at a certain distance. For analysis we are going to consider this eccentricity too, and that total force which is acting in downward direction, that will be W by 2. Why? Because we have considered it as a W by 2 because it will be sustained to the other part also of this governor. Now the height which I was talking about is the height of the governor, which is always measured, where the two arms are going to cross sect with the axis of spindle and is measured up to the center of that fly balls. So this is what the schematic diagram which we have seen for the analysis of forces in this Porter governor. One more term I forgot, that is the R, that is the radius of rotation of this fly ball. This radius of rotation is measured from center line or center point of this fly ball to the center of the spindle. This is considered as a R. Now all these forces are calculated. Here we can see. First of all, we'll consider this point D where the forces are acting. We'll consider this D is in equilibrium condition, that is the force which is acting in upward direction is equal and opposite to the force which is acting in downward direction. Now if we are going to see the force which is acting in upward direction, that will be the tension in this link. That upward direction force will be T2 cos of beta in upward direction, whereas this W by 2 is acting in downward direction. Now these forces will be in equilibrium condition, that we are going to consider. So we will consider that equilibrium of forces at point D. What will that forces? That is T2 cos beta is equal to W by 2. Now this W is placed as a M into G divided by 2. So this T2 cos beta is equal to mg divided by 2. Now we have to calculate this T2 because that we are going to use later on for the solving of this all force analysis, and that will be equal to capital M into G divided by 2 cos beta. That cos beta will come to this side and it will become 2 cos beta, which will be in numerator or denominator of this equation, and we'll say this as a equation number 1. Likewise, we'll consider the forces which are acting at point B. Now which are the forces acting at point B? First of all, the centrifugal force which is acting in a horizontal direction and in outward direction as far as the governor is concerned. Second force which is acting is the weight of that fly ball. Third force which is acting is the tension in this arm. Fourth force which is acting is the tension in this lower link. So this 1, 2, 3, 4. These 4 forces are acting at point B. And here also we are going to consider the equilibrium, because when the governor is going to rotate, and if it is in equilibrium condition, then and then only this sleeve will not move in up or down direction. And if it is move, then we have to calculate, or the speed will get changed, right? So here we are going to consider these forces which are acting at point B. First force is centrifugal force, Fc. then weight of that fly ball W, then tension in upper arm, that T1, and tension in lower arm, that is T2, that we have. As we are going to consider the forces which are applied or which are acting on this point B, that forces we are going to consider here. This is point B, centrifugal force which is acting in horizontal direction, W which is acting in downward direction, T1 that is the tension in arm which is acting in the direction of that arm with the angle alpha which has made with the vertical, whereas T2 is the force which is acting in downward direction which has make angle beta. Now in this case we have to just resolve these forces in vertical direction. First of all, we will resolve all these forces in vertical direction. So which are that forces? This T1 will become T1 cos alpha, here T1 cos alpha, whereas this W is acting in downward direction, and this force will also get resolved in the vertical direction, and that will be the T2 cos of beta. Now if you are going to see the addition of all these forces, then what we are going to get here is the forces which are acting in that direction. So now upward force we will consider as a positive, downward force we will consider as a negative. So we can write this equation as T1 cos alpha upward force is equal to the all downward forces which are acting, so that it will be in equilibrium condition, that is T2 cos of beta plus this W which is acting in downward direction. Now in equation number 1 already we have calculated value of this T2. We can put here from that equation number 1, that is T1 cos alpha is equal to T2 is equal to what? mg divided by 2 cos beta. That value we have put here. This cos beta will be as it is plus W. Now this cos beta and this cos beta will get cancelled, and we can get clearly equation that T1 cos of alpha is equal to capital M into G divided by 2 plus small w. We'll consider this as equation number 2. Now as we have resolved forces in vertical direction and we have considered the equilibrium of that forces, now we are going to consider the resolution of forces in horizontal direction, because not that vertical forces is sufficient or nor this horizontal force analysis is sufficient. We have to do both, that is vertical and horizontal force analysis, because these two forces are acting at certain angle. That's why they are contributing to the horizontal forces also and to the vertical forces also. So when we are going to consider the horizontal forces which are acting, first of all the centrifugal force which is clearly acting in the horizontal direction in towards left side, we'll say. Now this component of T1 will act here, this will get resolved, and this will be T1 sin alpha. Also we are going to resolve this T2 force, that will be T2 sin beta, that is here T1 sin alpha, this force, and T2 sin beta, this force will get resolved at the horizontal direction. There will not be any equation of this W, because W is acting vertically downward direction. So if you are going to take any component of W to the horizontal, it will become 0. So we are not going to consider it. Now we are going to consider this resolving forces in the horizontal direction. Just we have resolved it. We will consider the equilibrium in horizontal direction. So only one force is acting towards left side and other forces are acting towards right side. So we'll consider here equilibrium, that equilibrium sign here. This is the left force which is acting, that is centrifugal force F suffix C is equal to T1 sin alpha, first force, plus T2 sin beta, the second force which is acting. Now we can put value of this T2 which we have calculated already in equation number 1. From equation number 1 we'll put the value of T2 here, and that will be mg divided by 2 cos beta. So this equation will become T1 sin alpha plus m, that is capital M, central mass, into g divided by 2 cos beta into sine of beta. Now this cos beta and sin beta, for that we can write tan beta. So this equation will become centrifugal force is equal to T1 sin alpha plus mg divided by 2 into tan of beta. Now we are interested to calculate value of this T1 sin alpha. So when you want to calculate this T1 sin alpha, we have to take this quantity to the other side of this equal. So here we are going to write f suffix c minus this we are going to take to the other side will become minus capital M g divided by 2 tan of beta is equal to T1 sin alpha. We'll say this as equation number 4. Now what we are going to do is that already we have calculated equation number 4. We have calculated equation 3. So just we are going to divide this equation number 4 by means of equation number 3. So our equation number 3 was T1 cos alpha is equal to mg divided by 2 plus w. This was our equation number 3. And equation number 4 was T1 sin alpha is equal to fc minus mg divided by 2 tan of beta. Just now we have calculated it. Now when we are going to take equation number 4 divided by equation number 3, that is this equation divided by this equation. So it will be T1 sin of alpha and divided by T1 cos of alpha is equal to this centrifugal force Fc minus capital M g divided by 2 tan of beta divided by capital M g divided by 2 plus small w. Now this T1 will get cancelled and we will get this equation as tan of alpha is equal to Fc minus capital M g tan of beta divided by capital M g divided by 2 plus w. As we have calculated this equation as a tan alpha is equal to Fc minus mg divided by m2 into tan of beta whole divided by capital mg divided by 2 plus w. From this equation now we'll take this part to the other side of equation. What this equation will become mg divided by 2 plus small mg. I have placed the small mg in place of this w. So mass of that fly ball into gravitational acceleration. This will be in bracket multiplied by tan alpha as it is. Remaining part to this side will be Fc minus capital mg divided by 2 tan of beta. Now what we'll do, this tan of alpha will take to the other side. So this equation will become mg divided by 2 plus small mg is equal to Fc, that is the centrifugal force. This part we are going to take on this side. So divided by tan alpha minus mg divided by 2 divided by tan of alpha. This tan beta divided by tan alpha. Now at this place what we will do, we will just simplify this equation by means of putting this tan beta divided by tan alpha is equal to one quantity q. Okay, this tan beta divided by tan alpha is equal to q, that we have put. Now from diagram, which diagram? This is the diagram. This angle is alpha, this point is B point, this point is P point in that governor's diagram. This is lower R, centrifugal force is acting in this direction. So we'll consider triangle BP here, we'll consider as a M. In this triangle, what we can write for this tan alpha? This tan alpha will be R divided by H. So tan alpha is equal to R divided by H. That value we will put here. Now let us consider this tan alpha is equal to R by H from the diagram. This diagram we have put, and from this diagram we have put tan alpha is equal to R by H. In the equation which we have calculated, in this equation we will put all over these values. So what will happen? This will become mg divided by 2 plus mg. Then we are going to put centrifugal force Fc is equal to mr omega square multiplied by tan alpha is what? R by H. It will become H by R. h by r minus mg divided by 2. For this tan beta divided by tan alpha, we are going to put some quantity as a q. As we have calculated this equation, mg divided by 2 plus small mg is equal to small m omega square r into h by r. This r will get cancelled to each other, minus capital mg divided by 2, this quantity q. Now we'll rewrite this equation as we have cancelled this r. It will be mg divided by 2 plus mg small mg is equal to m omega square h will remain only here, minus mg into q. Now if we want to calculate only for this quantity, that is m omega square h, will keep as it is here, and this mg divided by 2 into q will take to the other side. So this will write first, that is m omega square h is equal to this value mg divided by 2 plus small mg divided by 2 plus small mg plus this quantity we are going to take this side, so it will become positive, capital mg divided by 2 into q. Now what will happen here, we are going to just calculate this m omega square h is equal to this mg will write first, and from this quantity and this quantity will take this mg divided by 2 as a common. Here what will remain? It will remain only 1. Here what will remain? That will be the only q. So we are going to take this capital mg divided by 2 common. In bracket it will be 1 plus q. This mg will be as it is here, small mg. So this equation now we are going to rewrite in form of h, so that this m omega square we are going to take to the other side. So h will become small mg divided by the small m omega square plus capital mg divided by 2 m omega square. 2 was there initially, only we are divided by this m into omega square. Into bracket this 1 plus q will be there. So this m will get cancelled, and we are going to get the equation as h is equal to, we'll take this g divided by omega square. Here also we'll find this g divided by omega square. This will take common. So what will remain here? If you are going to take the g divided by omega square common, it will be remain only 1 plus here what will remain, that is m divided by 2 into 1 plus q, m divided by 2 into m into 1 plus q, and whole bracket we are going to take this g divided by omega square as a common. Now if we want to solve this equation for omega square, we'll take this omega to this side and h to the place of that omega. So when we are going to rewrite this equation, it will become omega square is equal to 1 plus capital M divided by 2 small m into bracket 1 plus q, whole bracket complete, into g by h. Omega square we have placed here and h we have placed in the place of omega. So this omega, what is that omega? That is angular velocity, which we can calculate as 2 pi n divided by 60, where n is the speed of that governor. So n will become 60 into omega divided by 2 pi. So in place of omega we will put this value, and here we can get this equation as a n square. We are going to put value of omega square here. N square is equal to 1 plus capital M divided by small m 2m into q plus 1 in bracket complete. G by h was there, so this we are going to take at the other side. It will become upper part of this equation. So here it will be 2 pi divided by 60 bracket square. So this will be that. Sorry, by mistake I have written it as a 2 pi divided by 60. It will be 60 divided by 2 pi whole bracket square. And now governing equation of this Porter governor will become n square is equal to 1 plus capital M divided by 2 small m into 1 plus q bracket complete whole bracket complete. This 60 divided by 2 pi square that we have calculated, and it will be 895 divided by h. This will be the governing equation of Porter governor, and we can solve problem related to the Porter governor by means of this equation, where what we have to mention, this q is equal to tan of beta divided by tan of alpha, that we have to calculate. And what is this tan alpha? Is equal to, that already we have calculated as h divided by r. From this diagram we can find out, from this diagram, where the point G was and this was the angle beta, how we can calculate this tan of beta? That we can calculate as tan of beta is equal to sine of beta divided by cos of beta. From this diagram of governor we can say this is the radius. We'll consider this as the eccentricity E from this point G to the center of spindle. Now remaining value will be r minus E. Now to calculate value of beta, what we are going to do is that we are going to take sine of that, considering that L is the length of this link, which we can calculate from the previous equation. So here, if it is considered that all arms are having same length, then from this equation we can calculate value of L, and this value of L we will consider here. So this beta angle, we can take sine of beta, that is r minus E divided by L. This will be sine of beta. Now beta value can be calculated as sine inverse of r minus E divided by L. This value of beta we can put in the equation for calculating tan of beta, and we can solve the equation in terms of n square.